All right, here we go. 2.8a. How do we transform equations and graphs? I apologize, the handwriting is not good. I'll read it again. How do we transform equations and graphs? So the first one, okay, for part A, we are going to state the transformation in words, and for B, we're actually going to write the new equation, okay? On the back side, we'll get to the graphs. So this 1/2, all right, we are going to be using void. Why are we using void for this bad boy? Because it's outside of the parentheses. So this is going to be half as far from the x-axis. So this is going to be affecting the y's, so that means we're moving away or towards that x-axis right there. Okay. So what does that 1/2 do? Well, now we're going to take 1/2 to write the equation, 1/2 of all of this. Well, that's not so hard, so I'm just going to write 1/2 of all of that. On the regents, unfortunately, that's not what you're going to see. They're actually going to multiply it in, so you are going to have to do the same. Distribute it in and come up with your answer. So 1/2 times x squared is really hard. It's 1/2 x squared. Nothing changes when you multiply a constant times a variable. You just put them next to each other. When you multiply 1/2 times -4, you are going to get a -2. All right, let's move on to the next one. So now we're taking the absolute value of x minus 5 plus 2, right, and we're transforming it by x plus 3. Okay, well, this is going to move this whole thing left 3. It's inside parentheses. This is your Hicks, so it's horizontal, it's inside, and it is affecting the x's. It's not going to affect the y's. It's just taking the whole graph and shifting it left 3. So we're going to take and replace the x with an x plus 3 to change this equation. So it will become x, write it up here first, x plus 3 in place of the x, and then I'll tack on my minus 5, and then a plus 2. Okay, so that's what we had. We replaced the x with an x plus 3. We can simplify that a little bit to write the answer. The -5 and the +3 make up x minus 2, and then we keep the outside the same. That will take the whole graph and shift it left 3. And if you're not sure, you want to double check, you can type all these into the calculator just to see that it actually is happening. All right, next one. We are inside, so we are dealing with Hicks. So it's horizontal, it's inside, which means it's going to be opposite what we'd expect, and it's going to be affecting the x's. So 4, opposite, means 1/4. 1/4 as far. If it's affecting the x's, that means it's moving it, all right, away or towards the y-axis. So it is 1/4 as far from the y-axis. So when we make our substitution now, we have to replace the x with 4x. Okay, so it was x squared. It was the x squared minus 4. But we're going to replace the x with 4x. So we have to actually do 4x squared. It's really not hard. 4 times 4 on a good day is 16, and x times x is x squared. Subtract off the 4. Please write a 4. All right, there we go. And we're all set with that one. Let's do another one here. Square root of x minus 10 is transformed. Ooh, we got 2 transformations going on here. Doesn't that look fun? I know you're saying it looks fun. So we have a +4 inside. We have a +2 outside. Remember, inside is going to be a left-right movement and opposite. Okay, so we're dealing with Hicks. So this is going to be left 4. It's opposite what we'd expect. And that +2 is outside, behaves as we expect, so it's up 2. So what's going to happen to the equation? Well, we're going to replace the x with this part, and then outside we're just going to add the 2. So it's going to look something like this. There's the equation. We now are taking the x and replacing it with an x plus 4. That wasn't so bad. And then the outside the equation part, the void part, is +2. So that's got to be outside. Remember, that's outside the parentheses, the square root of the absolute value. Okay. So we have our new equation of the square root of x plus 4. The -10 and the +2 make a -8. All right, next question. X squared plus 1 transformed by, yep, 2 things again. Tons of fun. We have the outside parentheses. That is multiplication. As soon as it's multiplication, we know we have to be saying it's something 2 times as far or half as far. Outside, all right, is affecting the y. So if it's affecting the y's for void, all right, that means it's going to be from the x-axis. You're changing what the y's are. That means you're getting away closer or towards or farther away from the x-axis. So this is going to be 2 it behaves as you expect. So this is 2 times as far from the x-axis. And this plus 1 inside parentheses, again, inside parentheses is opposite what we'd expect. It's not multiplication, so we don't have to worry about flipping anything, but it is an adding, so it's opposite, so it's going to be left 1. The equation, all right, the equation is something squared plus 1. And now I need to make my replacements, my substitutions. It's supposed to be 2 times the whole thing. So 2 multiplied by the whole thing. And then I have to do that plus 1. Well, that plus 1 ends up going inside of replacing the x. So here I have the x plus 1. That's not going to be a whole lot of fun. So I'm going to have to do the x plus 1, right? So it's 2 times my x plus 1 squared, and then multiply the 2 into the other part, plus 2. Now, I don't have enough room for it here, but on the Regents, you can bet 100% certainty that that is not going to be the answer for the multiple choice question. They are going to do x plus 1 multiplied by x plus 1. They're going to FOIL it out, then they're going to multiply the 2 in afterwards, and then they're going to add the 2. So it's going to be a lot more work, but that's the idea behind it right there. No. Oh, you stink. All right, let's finish this up. Got it figured out as best I can here. So we have f of x equals 4x squared minus 1 is transformed by minusing a 2. That's going to be Hicks because it's inside, and here is the void outside. So the minus 2 inside, horizontal inside, it's affecting the x's, so it's going to move it right 2. Don't forget it's opposite, so this is right 2. And then that plus 5 is going to move it up 5. So how do we change our equation? I'm going to write this down below because I have the room there. So we have the whole equation is supposed to be 4 times something squared minus 1. The part that we're going to put inside parentheses is the replacement of x minus 2. And then we have to add on that plus 5 at the end, and then we're good to go. So we'll have 4 times the x minus 2 squared, and then it should become plus 4. Don't forget, the Regents is going to FOIL that out just to make that question more enjoyable for you. Yeah, that's right. Let's move on to the next page. All right, so we are first going to state the transformation in words here, graph it, and then write what the new equation would be. All right. Now, I don't know which one the Regent's going to ask you to do. It's never going to ask you to do all 3. This is just making it easier for us to do it and not have to do as many problems, I guess. So we're doing more with the same thing. So the first problem has a minus 2. Come on, start working. Stupid thing. Minus 2, which means right 2 because it's inside parentheses, and a minus 3, which is down 3. You do have to memorize that stuff. It isn't a whole lot of fun. So we have right 2, down 3. So how do we do that on a graph? Well, it's actually really, really easy. You find points that are nice points. People call them lattice points, points where it's easy to figure it out. Right? One point would be right here. It's very hard to do that on this iPad, I'm just going to say. All right, that's my excuse as to why this is horrible. So I'm going to take each point that I just plotted there. Those are on lattice points where the x and y lines intersect. And I'm going to move it right 2, down 3. So right 2, down 1, 2, 3 is right here. Again, that was right 2, down 1, 2, 3. I'm going to do the same thing here. Right 2, down 1, 2, 3. Right 2, down 1, 2, 3. And just in case you didn't get it, right 2, down 1, 2, 3. How obnoxious. All right, so there they are. Now I play Connect the Dots. It's a fun little game that you got to play back in kindergarten. Look at that. Aren't you living the old glory days of kindergarten when life was so much easier? All right, there we go. There's the graph. So now I have to write the equation. Okay? Come on. So we have 2 to the power x. So it's 2 to the power of something that should be x. All right, so what am I going to put in place of that? Well, I have to replace inside the parentheses with an x minus 2. And then outside of parentheses, that's after everything, take the whole equation and subtract 3. And that should say x minus 2, but it's just a real crappy mark. All right, so 2 to the x minus 2 minus 3. You'll see that equation shift right 2 and then down 3. Take a look at this next problem here. We have to multiply it by 3. This is going to be your void. All right, we're dealing with what's outside, so it's vertical. It is outside of parentheses, and it's going to be affecting the y value. So it's going to make this thing grow, and it's going to be farther from the x-axis. So this is going to be, as we expect, 3 times as far from the x-axis because it's affecting the y values. When you affect the y values, all right, it's making it go away or towards the x-axis. So 3 times farther from the x-axis, in fact. So we're going to take each one of these points, okay, and I'll find some nice points again, those lattice points that you're talking about. Right here. Yeah, that was horrible, I missed. Right here, and maybe right here. Those are 3 good points, all right? This is our square root curve. Notice it has that starting point. That's kind of a neat, unique feature about that curve. Anyways, 3 times farther from what it was. And this is where you need to pay attention. So this point right here is 2 units, right? 2 units away from the x-axis. And this is why we write this way for this specific question. If it's 2, it's now got to become 6, which conveniently or inconveniently enough is not on the graph. That stinks. So it's going to be down 6 away. So it was 2 below. It's now going to become 6 below, which is right here. This point right here that is 0 away from the x-axis is still going to stay at 0. This point right here that is 1 below the x-axis is now going to become, or 1 above, is now going to become 3 because it's 3 times farther than what it was. So 3 times the 2 below is 6 below, 3 times 0 is still 0, and 3 times 1 above will be 3 above. And then you get to go back to the glory days and play connect the dots again. Yay, there it is. And there is the equation. Again, we're 3 times farther from the x-axis. So this is 6 below, this is 3 above. Every point is 3 times away. So this is outside parentheses. When we're writing our equation, we're just going to multiply 3 times this whole thing. So it's 3 multiplied by the whole thing, square root of x plus 4 minus 2. We can multiply that in. You multiply 3 times the radical, 3 times the 2. That's going to give you 3. You multiply the radical by the number in front, so 3 times the square root of x plus 4, 3 times the 1 in front gives you 3, and then minus 6. Okay, in the last problem here we have f of 1/2 x, and this is the one that gets people, okay? So here we are dealing with Hicks. It's inside, and you have to remember that it's a horizontal, which means it's going to be affecting the x. If we're affecting x values, we're moving away or towards the y-axis. So this is going to be opposite what we'd expect. It's not going to be half as big. It's going to be 2. That was supposed to be a 2. Let's try again. 2 times as far from the y-axis. Okay, so 2 times as far from the y-axis. So find your points. There are my points. All right. And I need to make them all 2 times as far from the y-axis. And again, if you're writing it using that language, it makes this part easy. So 2 times as far from the y. Well, it is 1, 2, 3 away. That is 1, 2, 3 away. These are 2 away. This one is 2 away. This one is 1 away from the y. This guy is 1 away. And this one is 0 away. So we're going to multiply them all by 2. So that's now 2 away. That's now 2 away. This was 2 away, so it's got to be 4 away. This guy right here was 2 away, so we're going to make it 4 away. This one was 3 away, so it's got to be, again, off the graph. That won't happen on the Regents. I can almost guarantee that. And there you have it. So this guy is 0 away, and 0 times 2 is still 0. So play connect the dots, and you now have your graph. Wow, that's a horrible job. All right, last thing, we need to write the equation. So 1/2 x, that means it's inside parentheses. We are going to be multiplying the x by 1/2. So the original equation was something squared minus 4. That something has to change to be 1/2 x squared. To change that one and multiply it out, you multiply 1/2 times 1/2. 1/2 of 1/2 is 1/4, or you can multiply it in your calculator, or 0.5 times 0.5. X times x is still x squared, which you end up with 1/4, or 0.25 x squared minus 4. All right, for the summary again, don't forget to fill it in here and get your practice done. Thanks.